Welcome to this GPON Network's knowledge delivery. It's part of our optical technology learning series. This pathway also includes courses on fibre handling and splicing, designing fibre optic systems, optical transport networks and G.709. There are advanced topics such as ribbon fibres, flex grid modulation and the latest amplification techniques. XGS-PON security. There are additional pathways available for layer 2 and 3. There's a link in the description if you'd like to get some more information. Now, let's jump into GPON and boost your knowledge.
To look at the course where it's designed to benefit people like yourselves requiring an in-depth knowledge of the principles and applications of passive optical networking, as well as understanding all of the fibre to the X applications. So it seems as though every day there's a new fibre to the something, as well as the associated equipment with it. So we find its flexibility and function within a modern transmission network. Some course objectives then. So we're going to have a look at the advantages of our PON or our fibre to the X type system and the variants. Look at the network elements and some of the designs. We'll have a look at supported applications and network interfaces. Synchronization methods in a PON network. So it's become very, very important. And I was looking the other day at your requirements with your Sienna equipment with the sort of common radio interface CPRI type systems. The timing, the synchronization required on that is infinitesimally tight. And we can look at one or two of their synchronization methods on that. Circuit provisioning and bandwidth requirements. And that always seems to be one of the main key enablers for you guys that want to learn all about bandwidth and circuit provisioning. Have a look at the upstream and the downstream issues of an asymmetrical system and a symmetrical system, both GPON and XGS and XGPON. Have a look at head-end and network elements. So we'll have a look at the optical line terminal, the optical network terminal. And then we'll have a look at a need for an effective network management system that's going to manage all of your devices, particularly when we're looking at protection mechanisms. And again, looking at some of the information that you shared with me, you're looking at protection mechanisms on your networks. We'll have a look at a capacity planning workshop. And then we've got some network testing with things like OTDR test sets and why that's important. So if there's anything else that you want covered in the course that we haven't sort of discussed and is already in there, then please shout out and I'll do our level best to try and incorporate that in. The first module then, we'll have a look at the definitions of all of these abbreviations. So things like fibre to the node, fibre to the curb, or indeed cabinet sometimes, fibre to the home. So where did it all start then? So it's an evolution of the passive optical networks. So we're trying to address the last mile of the comms infrastructure between the service provider's central office or head end, or indeed their point of presence, and a business or residential customer locations. Also known as the access network or local loop, the last mile consists predominantly in residential areas of copper telephone wires or coax cable TV cables or CATV. In metropolitan areas where there's a high concentration of business customers, such as you mentioned Quest, and I've also done quite a bit of work with Quest in the past. So the access network also provides high capacity synchronous optical networks or SDH or SONET rings. And typically, as you mentioned, your DS3s. So we've got 34 meg E3s and 45 meg DS3 links, as well as the copper-based E1s or T1 services. So let's have a look at the introduction then. So we're going to have a look at why we're going to be using the fibre types and why indeed single mode fibre. One of the issues of having a passive optical network, so the idea of a passive network is that we haven't got any active components between the OLT and the customer side equipment, so that reduces the costs. It also reduces the maintenance costs. So if there's no active components in the network between the two ends, the two head end and the customer side, there's a reduction in maintenance. So no truck rolls to go and fix equipment. upload software on switches, that type of thing, power outages. That then looks at giving us a quality of service improvement. And have a look at the customer-owned access points, whether they're going to physically own their own equipment or you're going to lease hire it to them. And we'll have a look at some of the limitations of the old DSL type services, digital subscriber lines and hybrid fiber coax. And indeed, as you've mentioned about satellite systems, and limitation of direct broadcast systems. So you've got a downlink, but no return path, so no triple play services. Cost of connection. So one of the issues to overcome in the deployment of fiber systems is one of cost. Significant expenditure is required to install fiber to each house from the exchange. And I saw on a website of a company that you may know probably about 15 years ago, and that was the Cisco website. And I reckon the estimation was that it costs $35,000 per kilometre to install new fibre. So I don't know what the cost of that is today over a 15-year incremental. But that's sort of some of the issues, is that digging up the streets, getting the wayleave to install the fibre, and trying to get the right approach from the fibre, as in the physical approach down the streets, can be some phenomenal hurdles to try and cross. So the cost of installation and maintenance of the fibre plant and the active components is key, and one of the issues is having a good management system to do that. A bit of software will always be very, very advantageous to sort of map out where all of your endpoints are, where your central office is, and where the best routes are. So what is it we're trying to do? So with a passive optical network, we're trying to get over this last mile hurdle. And it is of note that a lot of people who are in the data world don't understand the sort of basic connectivity to an exchange or a local office. So this just goes some way to explain that. And this is sort of typical of what we got here in the UK. So we've got a home using a 64 kilobit per second telephone service. I think you guys will be more familiar with 56 kilobits per second. Going up to a telegraph pole in the street. And then there's a street cabinet where we say we've got the digital subscriber side and the exchange side. And then there may be bundles of copper pair cable going off to your local telephone exchange. Obviously, that limits the amount of throughput for that telephone wire when we're trying to use it for things like DSL to sort of fractions of a megabit per second. So probably 2 megs on the way down and probably only half a meg on the way back up if you're some distance away from the exchange. What has happened over the last few years then is that people like here in the UK, what Virgin Media, that you might know more so as Liberty Global, they're still branded here as Virgin Media. They do the hybrid fiber coax thing. So they've got their street cabinets and they're running out a coax cable to each and every house. It's what I've got at home. So that's then improved into the hundreds of megabits of throughput. But the single mode fiber is going to be the way forward. And indeed, certainly here in the UK, a lot of companies were trying to sell that sort of fiber to the cabinet type service where the cabinet was fibered, and then we'll still be using the same copper cables to bring the service in. And there was some newer technologies which we can have a look at later on. So some of the abbreviations then, and it can be a bit of a minefield. It seems as though every day there's some new marketing edge that someone's got on shall we say, an age-old sort of fashion way of doing things. And as we look into the 10 gig symmetrical stuff a little bit later on, we'll find a couple more. So we've got fiber to the home, where the fiber literally does that and goes all the way to the home. And obviously that's in a residential area. We got fiber to the curb, and it is of note that this is the North American way of spelling the word curb, not K-E-R-B as we do here back in London. Fiber to the business. So again, fiber to the business, or sometimes referred to as fibre to the building, sometimes we might say, but this is where we've got obviously then business customers, and that makes more sense financially because those businesses would then probably pay probably more of a premium for the service. Fibre to the user, fibre to the premises, fibre to the office, fibre to the street cabinet, so fibre to the cab, fibre to the node, fibre to the desk, which tends to be rather old-fashioned now, but I was involved in a project probably 13 years ago, getting some users basically logged on to a new computer system that was on multi-mode fibre. So that was only 15 years ago. And then fibre to the multi-dwelling unit, fibre to the single dwelling unit, fibre to the distribution point, and on and on and on. And every time you turn around, there's somebody got some new acronym that seems to be better than everybody else's acronym.
Thanks for watching the first part. Please follow the links above for the next part, or see the links in the description for info on our optical technology and other knowledge deliveries. As always, if you enjoyed our content, please hit like and subscribe, and also please feel free to comment on what you would like us to cover next. See you on the next one.